Welcome to Spring LIB.
Our question says that we have a wire that has a resistance of R, and then it tells us that we have another wire that has a length. So we're going to call this other wire wire 2, and the original wire wire 1. So the other wire has a length that is 1/2 the length of the original wire. So L2 is 1/2 L1, and it has a thickness, which I call D, that is 1/2 the thickness of the original wire. So D2 is equal to 1/2 D1. Now we want to find the resistance of the second wire based upon the fact that we know this information and we know the resistance of the first wire, R1 is equal to R. So we'll write that as well, just so we're clear on that. R1 is equal to R. Okay, well, we're going to use the fact that the resistance of a wire is proportional to the length divided by area. And the area is equal to 1/4 pi d squared. Well, we don't really care about the constants, so because we're going to be using ratios, and constants are going to cancel out in these ratios, so we can just consider the fact that this is proportional to d squared. Okay, so now we can go ahead and calculate the resistance of R2. R2 is equal to R times the ratio of the areas, A1 over A2, this is times L2 over L1. Okay, and this comes from just taking the ratio of R2 to R1 and using the information that was given in these two equations here, and here. Okay, so, well, as we discussed, the area is proportional to the diameter, and we know things in terms of, or excuse me, not the diameter, the thickness, and we know things in terms of the thickness or diameter, same thing here, and the length. So R is, we'll substitute in the fact that A is proportional to D. So D1 over D2 squared multiplied by L2 over L1. Okay. Well, we know D2 is 1/2 D1 and L2 is 1/2 L1. So this is R times 2 squared times 1/2, which is equal to 2R. So the resistance of the second wire is 2 times the resistance of the first wire. We'll box that in as our solution.